Hi everyone, today we will present you a graduation project by introducing the problem and defining it and defining the suggested solution in the İşbirliği Yatak Kanunu. This representation contains several sections. The first one is company information, the second one is problem description, the third one is mathematical model, the fourth one is validation, the fifth one is integration and explanation, the sixth one is comparison, and the seventh one is conclusion. I would like to start my representation by introducing you the company. İşbirliği Holding was founded in 1968 and İşbirliği Yatak was established in 1999 as an investment of İşbirliği Holding. The manufacturing area of the company contains two main assembly lines. The first one is covered mattress and the other one is sealed mattress. Due to high prices, the company has decided to procure required raw materials from their own facilities. These raw materials are used according to the receipt of products. The required amounts and the time intervals between supplying the raw materials are determined by material requirements level and bill of materials. After that determinations, the company decides to choose a supplier to purchase and order quantities to be purchased, considering the supplier's lead times, prices, and the minimum order quantities. When planning is done, it is seen that the company is still facing some problems. It is obtained that there is discrepancy between the monthly and yearly plans and procurements, and this discrepancy causes the purchasing to be inefficient and unclear. To solve this problem, a well-developed decision support system should be generated, and this system contains mathematical model, SQL database, and parameters due to different demand, prices, and lead times in different time periods. Now Lina will tell all about the mathematical model.
Hello everyone, I'm going to talk about the mathematical model. First of all, we have the sets. I for set of raw materials, J for set of suppliers where each alternative payment or payment and delivery, T for length of the horizon in the months. Here are the parameters. First parameter is for the minimum order quantities for each supplier J for each item I. Second one is price of raw materials I at the beginning of period T from supplier J. Third one is the total inventory capacity. Fourth one is the initial inventory levels for each product I at the start of the horizon. Fifth one is the demand for raw material I for period T. And the sixth one is the inventory level on hand at the beginning of period T for product I. The seventh parameter is inventory level for raw materials I at the period T. The next one is the penalty cost for having inventory less than the safety stock level. The ninth one is the amount of inventory level above the safety stock level. 10th one is the penalty cost for backordering. 11th is the initial budget at the start of the horizon. 12th one is the cost of a rental depot in period T. 13th one is the unit bill of raw material I. And the 14th one is the lead time for supplier J. And 15th one is the safety stock level of product I for period T. 16th one is the backlog inventory at the beginning of period T for product I. And the last one is the penalty cost for having inventory less than the safety stock level. Now we will talk about the decision variables. The first decision variable is amount of raw material I ordered from supplier J at the beginning period of T. Second decision variables are orders that will arrive at period T for item I. Third decision variable is a binary decision variable, and it accounts for if any depot is rented in the month T. And the last one is a binary decision variable too, and it's for if supplier J is used for item I in month T. Here is the objective function. Objective function minimizes the total cost of supply with the model development. The initial inventory constraint is the third one. This constraint is an initialization constraint. The model is included because currently Işbirliği has an inventory on hand. The fourth constraint shows the inventory balance. This equation updates the inventory after period t by also accounting for the inventory at time t minus 1. The fifth equation is the capacity constraint. First of all, this constraint ensures that the total value of arriving orders does not pass the total capacity. Secondly, it decides whether to rent an extra depot or not. Sixth one is the safety stock constraint. It is for the safety stock level for each item. Seventh constraint is the budget constraint. This constraint accounts for ordered items and whether a renting decision adds the amount of the constraint. There are two sets of 8 constraints. They are minimum order quantity constraints and they are if-then constraints, which ensures the orders above the supplier's minimum order quantity. The last constraint is a domain constraint. First part satisfies the binary condition, and the other part is about the non-negativity. The original project does not consider transportation cost in the model. This assumption is unrealistic and will not give accurate results. So we added the transportation cost aspect to the model, as it is one of the key parts of this operation in Greek life. We add one extra set, K for set of locations. And we have 2 extra parameters. First one is the transportation cost per unit from supplier J to location K. Other one is the available budget at location K. And we add one extra decision variable. It is for the total quantity shipped from supplier J at location K. And this is the main objective function. We added this part to the function, and this extra part calculates the total transportation cost based on multiplying the transportation cost per unit and total quantity shipped. And we have one extra constraint. It satisfies the total transportation cost, this part, does not exceed available budget for location K. And now my friend Yağmur